This report contains our recommendation for action that will help future pre-medical students increase their probability of being accepted to at least one medical school. If it were possible for a student client to improve their academic performance in just one of three main scoring areas, it will be on the pre-med GPA. It has the highest weight on the metric score we obtain through the optimization of the information gain. It clearly shows that there is almost no overlap between students that got admission to medical school to those that didn't. And also we test on the data set, having all other variables equal, just increasing 1 decimal point on the BCPN, their chances of admission increase by 12%. In regards to the undergrad major influence, we may think that when we apply to medical schools, we compete with all other applicants to the same medical schools. But the record seems not to be the same, because across different undergrad majors, the admission and rejection rate remains around 80%. So it means that even if you have not the similar or higher scores than someone coming from bio or biomedical school, just still get chances of admission. And we see that in the higher dispersion of an overlap of academic scores for non-bio or non-biomedical schools. So the undergrad major plays some role in the final decision of medical schools. Well, there is a space for improvement in our model. Academic scores and undergrad major are not the unique factors, so we would like to get more domain knowledge of the process of the admission to medical schools and incorporate more elements to improve our model. In regards to our scoring metric we develop a logit function incorporating the undergrad as a categorical variable and the mean center values of the test score of each student. Then we create a logit function and incorporate a sigmoid function to estimate a probability for each observation. Then, finally, we optimize the coefficients applied to each one of these variables in order to maximize the information gain. In order to calculate the information gain, the percentage information gain, we compare it to the initial entropy provided by the customer. It was 0.772 and 0.23. We calculated the doubling rate of well on the test set, and we did the division, getting a percentage information gain of 30.76% for this model. Well, all the statement of work and data set were provided by the customer. Whether you have any further question,